Hello everyone. Nice to see all of you here today on the regular webinar of gRPC. My name is Tatiana and I'll be your host for today. And our today's session is going to be devoted to topics related to gRPC, Kotlin, Protobuf, advantages, opportunities, pros, cons, and other features related to this technology set. But before the beginning, firstly, I'd like to say thanks for all of you who have joined us today. And guys, I'd like to ask you to post your hello messages into the chat, which you use for watching us. Please just keep us informed that you hear us and see us well on YouTube or gRPC platform, just in case, just to see that all of you are here and everything is fine. Yep, I see your messages. Thank you very much. Guys, firstly, one important reminder about our format. Please do not hesitate to post your questions on any platform which is convenient for you for watching the recording, for watching our event, our live stream. But we're going to have the dedicated Q&A session at the very end of the presentation for that purpose. So we will try to voice all of your questions. In case if we don't have enough time, we will post the answers on the gRPC talk page. So all the questions will definitely be answered. So please don't hesitate to add them together with your notes and thoughts on the presentation. And also, let me remind you that gRPC prepares regularly a lot of interesting content for you, so please do not hesitate to follow us and see more interesting events from us later on as well. And as of now, I think that this is more or less all with the intro. And let me introduce you to our speaker. So, Sergey Nikishchenko, who's a lead software engineer and will be our today guru in the area of Kotlin, Protobuf, and gRPC. So, Sergey, the floor is yours.
Okay, yes. So, hi everyone. Thank you, Tatiana, for introduction. So, let's start. So, yes, as Tatiana already mentioned, so we will speak today about gRPC, Protobuf, and it will work with Kotlin. So, short information about myself. I lead software engineer at Pump Systems. I have more than 12 years of hands-on experience with projects of different type, size, and domain, and 3 years at IPA. My current tech stack is Kotlin, mostly Java, Juice, gRPC, GCP, CloudScale, and Spanner. So let's start from what this tech talk about. So modern application architecture often involves distributed system with various services interacting with each other. RESTful communication has emerged as a standard approach for connecting these services. As time goes on, the number of inter-service interaction is likely to increase dramatically. REST, on the other hand, has significant drawbacks like performance. So I will present another approach of building inter-service communication, gRPC, and how to begin using it with or in place of REST. So I will start from some basic theory, and later I will show some more or less live example. So why Kotlin? The short answer, because it's pretty well made language. I like it so much, but let's go in more details. So Kotlin is a cross-platform static typed general purpose high-level programming language with type inference. It was designed to interoperate fully with Java. It mainly targets JVMs, but it's also composed to JavaScript for front-end application using React, native code for native iOS application, what works with Android applications. It was initially developed by JetBrains, but the Google is one of the main sponsor of Kotlin, and Google announced support of Kotlin as the first class language for Android development in 2017. Nowadays, it's not only language for Android development, but it's really nice fit to backend development, especially for working with gRPC. So during this presentation, I will show a few differences between Java and Kotlin. So the main Kotlin features in its conciseness and readability, null safety, and true immutability by default. It also provides some functional programming features, extension functions, and of course, what's quite important, it's pretty well interoperate with Java in most cases, of course. So, protobufs. Protobuf stands for protocol buffers. It's a language-neutral, platform-neutral, and extensible mechanism for serializing structured data. It's developed by Google and widely used for data storage, communication protocols, and RPC systems. Main features of protobufs: the binary format for efficient data exchange. Language, it's language and platform neutral, so seamless communication between systems, so they could be done on different languages, and you will see no issues with it. And extensible code generation, so simplified data manipulation, backward and forward compatibility for evolving application, what's quite important for huge product applications, and code generation. It's reduced development time and error potential. So next is gRPC. So RPC stands for Remote Procedure Call. which is software communication protocol that allows a program to request a service from another program on a network. While gRPC is a high-performance open-source universal RPC framework developed by Google. In gRPC, a client application can directly call methods on a server application on a different machine as if it was a local object, making it easier to create distributed application and services. I previously got asked, why did you split protobufs from gRPC? Because gRPC works with protobufs in this presentation. So the answer is simple, because gRPC could also use JSONs as a transfer object, while the protobufs could be sent over REST calls. So it could be just converted to binary format and just sent over the network. So it was done for compatibility to be able to use these technologies together with REST. So it could be quite useful for some cases. So here you could see the very basic idea behind the gRPC. So the gRPC server on left side contains gRPC server configured within it, while clients on right side has gRPC stubs to communicate with the gRPC server. Communication between server and clients are done using proto requests and proto responses. So key features of gRPC. It's much faster than REST due to binary data format and HTTP protocol. Its efficient streaming capabilities for real-time applications, automatic code generation, of course, in multiple language, and strong type and reduce errors. So to understand better what the difference, like let's see some examples, some drawings. So here you could see very basic simplified microservice architecture. So we have some browser what communicate with services using REST, and services communicate between each other using REST protocol as well. So what options do we have? On the left side, we could, for example, replace communication between services, so it could become gRPC, while the communication with browser are kept as REST. Or we could also replace our communication from browser to services, but as most browsers doesn't support HTTP2 protocol, we need to use gRPC web library, so it helps to bypass this issue. During this presentation, I will focus on these parts, so communication between services. So let's go to some real example. It used to be some coding example, but we don't have a lot of time and you don't want to see another hello world application, I suppose. So here I created an example application. It's utilized Gradle, and I've used Kotlin for configuration, Gradle configuration. So from interesting parts, I'm added a plugin Protobuf here. I will show it later. I put some dependencies required for gRPC, Protobufs, some REST, logging. It's not so interesting, but interesting part is here, the configuration of Protobuf compilation. So here to additional plugins configuration, so to compile our protos to gRPC protos to Java and Kotlin. And yes, here we will use also some additional Kotlin configuration. But let's start from REST example. So I have created a very simple, REST server here. It has few endpoints, so get all cars, so it's like a list operation. It's return all cars. Get operation by ID, so we search for our car. Yes, sorry, forgot to mention. So in our example, I will use some dummy car service. So it's information about some cars. So let's go back to our endpoint. So get by ID. So we search our first car by its ID and return it. And here you could see the difference between Kotlin syntax and Java. And as you could see, it, as I mentioned previously, it's more conciseness. Next action point is post, so it's car creation. So we add our car. So let's check our main object. It's pretty much straightforward. So it contains some IDs, some additional fields, some references, some list values, some nested classes. I don't think it's pretty much interesting. And let's start our server. And here I have a client. Clients have to call the URL. And later it's deserialize received object to our data class and print it to console. So yeah, as we expected, we received a response on our side. Simple, yes. I think most of you saw similar cases and work with similar approaches. But let's see how this similar example, such example will look like on using Protobufs and gRPC. First of all, yes.
Let me so interrupt you a bit because this is truly important in the current context. There is a question in the chat. What is this web framework which you use to handle HTTP requests here in services?
It's Ktor. It's
Okay.
Kotlin framework created for Kotlin. So it's lightweight. It's as you could see, it's allowed to create some endpoints in very simple way. So we don't create the boilerplate usually Spring requires. So it's used for simplicity, but it's widely used for different projects. So it's Kotlin framework. Yeah.
Okay, got it. Thank you. I see that some guys in the chat also made the right guess about this framework. So, yep, thank you very much. Let's move on then.
Yeah, sure. So first of all, we need to define our main object. So let's discuss the proto syntax. Protobuf has different versions of its syntax. The modern Proto 3 and default one is Proto 2. So the main difference is that in Proto 3 we don't have mandatory fields. And it's more modern syntax, so most of application have to has to use the more modern approach. So we define some package. We also could define optionally Java package, so to make our generated classes look more in Java style. As you could see, with just basic, so just adding com and some outer class, so codes generated from protos will be nested in some classes, so this will be name of the nested class. So to define the proto, we need to use a keyword message followed by uh, the proto name, and later we could define our fields. And one of the differences between our object I showed you previously, that's we don't have ID, but you could else ID if you want. So it will be not a problem. But Google provides also pretty well defined documentation how to approach and build well and standardized API using gRPC. So it's suggests to use instead of just IDs, but its name. So you could put all dependencies in the name. So it's quite convenient in most cases. So you could check this link and read more about how to build these names and how to use them and why do they need us. Uh, why do we need them? Yeah. So and protos support different types, so like strings, unsigned integers, just signed integers like this, longs, references, and lists. So from important things, we need to, for each field, we have to specify its index, because it's important, because different systems could map the data during deserialization differently, so we need to specify ELSA indexes. And if you specify index, so these indexes have to be unique. As you could see, we have warning that it's already exists. The value such indexes already here, so we can't use it. And one of the quite powerful features, as I mentioned previously, Protos provides backward and forward compatibility. So in case if we need to duplicate fields, we could put such additional option configuration. So this field will be crossed out, like in Java we used annotation deprecated. And when we in general approach do not remove anything from Protos. Do not remove totally any value, any fields from the Protos. So to be safe, again for compatibility. So to be sure that our deleted fields will not be picked up, to avoid some clashes, we need to reserve these indexes. So if I try to use it and it show me now, it's already reserved. Similarly, we could reserve also the field name. It's important when we serialize our Protos to JSONs and back, especially using gRPC Web, because it could match the fields using not IDs but field names. So we optionally could also reserve the field name. So beside that, tricky part, as I mentioned previously, Proto 3 syntax don't have mandatory fields. All fields are optional. So strings will be empty. String numeric values, it will be just 0. For references, it will be default instance. While for enums, we need to specify the value under the index 0. So it will be default value for enums. So usually the general approach to name it as the first part named as the enum itself, and followed by some unknown specified or any postfix to clearly show that this value is not set. At this point, if we compare our definition between our proto message and data class, it's pretty much simple with some extent, of course, but it's all not so important. We could use also int ID here. Okay, so what next? We defined our proto. Now we need to create gRPC service, so it will be like our common interface for this our service. It's again some syntax, some optional configuration for compiling, and what important here, to create a gRPC service, we need to use the keyword service and assign some service name. And to create a methods, we just put a RPC keyword followed by the name of the methods, value it's expecting, and its return value. I don't know why IntelliJ don't want to see these objects properly, but it's probably some don't pay attention to it. So here inside in this request, we receive just a name. So it's as we defined previously, nothing special, and return our proto we defined previously. And again, create operation, we receive object, return object. Pretty much simple. The list operation here a little bit more tricky because list operation could have much more different fields like order by, filter, page size, and page token. You again could go to IAP documentation and see details how these fields should behave and how they should work. And of course their syntax, because filtering, for example, has own syntax. But you could implement wherever you want, of course. And here I put more advanced case. So it's update car. First of all, here it's receive object to update, and I put here optional field update mask. In general, field masks in Proto in gRPC it's quite often parameter. It means that we need to work with only with fields specified in these field masks. So, for example, if you request some data, some huge amount of data, for example, for a list operation, and you put some field mask, so you will receive only data you're looking for, not the full data of the object, but the only field you're searching for. What could also additionally increase performance of your application. And here I've added additional fields. They are described in our in this documentation. What it's for? It's for supporting HTTP calls protocols. So in general, our gRPC services have to be able to be reached using HTTP protocol. So we need to create a mapping from gRPC service to HTTP. So patch operation will work under this path, and here we also in general this is the path, but it will be assigned to these fields. Car name, car, it's the object in the body, and it's also stated here. So we are talking about this object within this update request. And in general, that's all. So If we're talking about simple definition, it's pretty much simple. So, like we are doing in Java when we create some interfaces, just basic description. What next? Later we just click build and Gradle will do everything for us. Uh, yeah. As you could see, we got generated gRPC KT. gRPC, its classes built for Java, and gRPC KT, it's built for Kotlin additionally. So, but you could use either of them. And also here we have some classes built for Java and some additional classes for Kotlin. Kotlin provides also possibility to use Kotlin DLS for creating new objects, what quite useful, and I will show it a little bit later. So let's go to, okay, so we defined our interface. What to do next? Of course, implementation. So we need to implement our interface. So as I showed you previously, this is the class what was generated by Gradle. It also generated some abstract class here. So we need to extend it. It's also contains all methods we just described, but they are just throwing errors. We don't need any exceptions. Okay, so first method, get car, first or null. So we search for first value in our list, in our stored cars, of course. If it's not null, this Elvis operator means return previous value. So if it was found, it will return it. If not, return what goes next. So here the empty object. In Java, it will look like here car get default instance. So this line of code in Java will look like this. So stream filter find first or else default instance. For car creation, we have as request a car and we are returning a car. Of course, as it's a new value, we don't have any ID assigned, so we just generate some ID, in our case name, store this car and return it. Simple, pretty much. Later list operation is also just we create an object. It uses Kotlin DSL. So we just put all our stored car in this proton field cars. And that's it. So I have pretty simple implementation here. Before we go forward, I would suggest to compare object creation. So here I created some objects, how it's look in how looks proto creation in Kotlin using Kotlin DSL, or how it looks in Java. We use Java requires using builders, so we need to use setters. And for list values, we just add list values. So, and of course, building after. But if we want to compare it with data class creation in Kotlin, as you could see, almost no difference, right? It's pretty much the similar. So everything are almost the same with some extent, on some extent. So it shouldn't create any confusion for people who start working with Protos. Okay, let's go back to our service implementation. So we have interface and we have implementation. What to do next? We need to publish somewhere our service. I mean, we need to start it. To be able to do it, we need to create to use server builder. We add in a service. We could also optionally add some interceptors like logging, data manipulation. So add some additional fields or transform something or some up to you in general. So depending on the project and needs, but it's quite convenient. So I've started our server. As you could see, the server configuration is really simple. In general, same for the client. So first of all, we need for client we need to create the stub. Stub requires the channel to be able to connect to the server. So we use manager channel builder for our local host using the port, the plain text channel. You could use SSL if you want and configure it within a real project, and of course optionally some interceptors. Later we need to create a stub so to be able to use it. So again, our car server's gRPC KT file, and it has such method which expects channel, and we have our stub. Now we create some basic request and just executes this method like it's on our local machine. Okay, and as you could see, we received our object we searched for. So the client creation, it's also pretty much simple. So um, of course, server creation and client creation, it's often is quite simple stuff, but in real project, we also need to create some test coverage. Let's see what we need to create a unit test using gRPC infrastructure. So the main part here, we need to create gRPC cleanup. Later, we generate some server name to avoid some collision during the test execution. Within this gRPC cleanup, we use in-process server builder. Previously, we used server builder. Right now, we need in-process for testing purposes. So for this generated name, and we are adding our service implementation here, and we are starting it. That's all. And we need to create a stub. Again, our generated class, the same method as previously in client, but the difference here, the gRPC cleanup needs to register in process channel. So we built the in process channel for the same server name as previously, and that's all. So now we have a client as well. After that, our tests look pretty much straightforward. So we are creating some requests, we expecting some results, we executing the service methods like it's our just local class, but it's gRPC service, and doing some validation. So like we usually do our unit testing. Um, so yes, this is how to implement the same behavior using protobufs and gRPC, but I have one additional example, more advanced. As I mentioned previously, gRPC has pretty good streaming capabilities. Someone could ask, but we have WebSockets for it. Why should we use gRPC streaming? Because again, the reason is the same: performance. Because gRPC could multiplex requests, so it could use one channel to serve different requests, while web channel doesn't allow to do it. WebSocket, sorry. Let's see our example. So again, we need to start from service definition. It's very simple service. It's car feed service. We want to subscribe to our feed. So some very simple requests. It contains some values. So it's dummy filter here. At its return, pay attention on here: stream and object. Object contains our previously created proto and some stamp of submission. Simple, of course. And what next? Similarly as we did it for the general service, but the main difference here in this method getCarFeed, we receive request. As a return, we return a flow instead of plain object because it's streaming. For Java, it will be a stream observer or some other options as far as I remember. So we return the flow. Here I created a loop. And to send some values within the stream, we need to use emit and put some values inside it. So it will be sent over the stream. Here I created some generator from the list below. And I put some delay to replicate real behavior, some feeds publishing. And we need to add it's a service to our server. And as far as I remember, it's executed. So nothing special, almost the same as it was previously. And I have a client here, the same channel creation, stub creation, and method execution. The only one different that here, as I mentioned previously, we received a flow instead of plain value. So to proceed to handle our return values, we need to collect it from the flow. So it will be collected immediately after arrival. So here you could handle it as you want, but I made just basic printing out. And we started, we received one object, we received another object, and one more. We have some submission timestamp on, of course, our new values, and so on and so forth. Okay, so that's all from the coding.
And I think, just a tiny note. I see in the chat discussion regarding the data flow. Guys have already shared some insights, and I think you have also mentioned some related points in this particular piece of your presentation. So I think this topic can be considered as covered. Before we return back to the presentation, just to make sure that we have covered all the questions so far. One more question is, are there any tools for generation of proto files from, for example, Java classes, or so from classes on like from POJOs, let's say?
But in general, generally, Proto-C is used for compiling from Protos to the language you need. So I'm not really understand the question, because you have for your language you always have the same object from the same proto.
So basically, this is kind of reverse engineering. For example, we have like Java POJOs, and we would like to generate proto files from them. Are there any tools for that?
Okay, in general, I don't think it will be quite simple, but because of a lot of additional code required for Protos, as you could see here, it has a lot of different code. So
Yep. I think so. Do you share the screen?
no, sorry.
Don't seem to.
Probably yes. Let me.
Enabled. Yeah. Actually, yep. I agree that so the basic skeleton can be generated kind of simply, but there are a lot of stuff happening around, so possibly it might be kind of tricky to generate it back.
Yep. Most likely, probably you could search for some tools what could just transform your Java Protos, Java files, data model or data record files.
Yep. And I truly like, by the way, the answer to this question in the chat. You can always throw your Pojo at GPT and kindly ask to transform.
Yeah,
So this is kind of an interesting option as well.
Yes. So, but as for me, it would be a bad practice, just use some automatic tools, because during proto creation you could rethink a little bit your data structure, and rework it, probably optimize in some cases. So it's also could be quite useful.
Okay.
And again, as you could see, we don't have a lot of difference between proto definition and the project classes, data classes, records, etc. So it's almost the same, besides these IDs assigned. So
Okay. Yep. Guys, I see the questions and comments which have just been posted. So let's leave them to our Q&A part, and then let's jump back into the presentation then.
yes. So of course, so I showed you code example, but in real project we don't use only core features, because it doesn't conform all our real prod needs and expectations. So this I gather some basic list of different gRPC tools what could be quite useful. So for monitoring and testing, I would highlight from this one, it's OpenTelemetry. It's collection of APIs, SDKs, and tools to create and manage telemetry data, logs, metric, etc. gRPC Replay, it's a network monitoring tool that records gRPC traffic for load testing, monitoring and analysis. So you could replicate some, you could record your network, real network traffic, and replicate it later to see how your application behaves on high loads. And it could be quite useful for integration testing, because you don't need to create some external gRPC services, for example. You could use gRPC Replay for it. And of course, Postman. It's well-known tool. It's also support gRPC, so you have bunch of other tools and a few load balancing tools. Some of them on Nginx, widely used web web server and traverse proxy. It has simple setup. gRPC client-side load balancing, so gRPC has some built-in mechanism, so it's good for some specific cases. Main cloud providers has own load balancer, what works pretty well with gRPC. So AWS, GCP, and Azure provide them for sure. So let's go to the summary of this presentation. So gRPC utilizes protocol buffers to define service contracts, ensure clear expectation and type safety between services. The contract-driven development minimizes errors and promotes more robust communication. gRPC makes communication between services a breeze. Forget managing endpoints. Just simply calls methods directly on class, because it's much more convenient than sending the notification to some endpoints. So just call methods, that's all. This intuitive approach comes with a significant boost in speed and efficiency, all while requiring a similar amount of code as traditional methods. Yes, but of course, it's real life. So in software architecture, we don't have a silver bullet, so everything is trade-offs. So the real choice between gRPC and REST depends on your specific needs and priorities. Here are some factors. Performance, if your application requires high performance and low latency, gRPC is a better choice. Optionally, you could also use gRPC for the main crucial parts of your application, what requires high performance and low latency. So not for all application, but part of it. Complexity, if you need a simple and flexible API, REST might be simpler to implement. And sometimes it's simpler because of developer experience. Most of teams is familiar with HTTP and JSON, so REST might be easier to adapt for such teams. Ultimately, you can also consider using both gRPC and REST together, leveraging the strengths of each for different parts of application. For example, as I showed previously, so the browser could communicate with services using REST calls, while the interaction between services could be done using gRPC. I put some useful links here. On the number one, I put the link to the code I just show you. Information about Protobuf, documentation about Protobuf, gRPC, Kotlin itself. It has really good documentation, and IP dev documentation. So it's a set of documents how to build standardized gRPC services. So yeah, thank you for watching. Any questions?
Thank you. Thank you very much. Thank you for the great and informative presentation. We do have some questions and comments,
Sure.
and we will try to cover all the part which hasn't been covered yet. The first question, which hasn't been voiced yet, is about whether it's possible to use gRPC with WebSockets.
But what for? The main question.
Oh, okay, that's interesting. Could you elaborate on that a bit?
But by the way, I highlighted it. So if you using already gRPC somewhere in your system, it's makes sense to create gRPC streaming because it's has much better performance. And as for me, it's more convenient, just call a method rather than calling some endpoints and try to understand what you receive as a return.
I see, I see. So this is definitely not the best practice.
Yes. In general, as I mentioned previously, gRPC could work with JSONs as a main transfer object, but I don't think it's possible to connect web sockets with gRPC.
I see, I see. Thank you. Also, there was a note in a chat, just pay attention to Protobuf version 2 or 3. Basically, version 2 should be avoided if possible.
Yes, it's pretty much old, as I mentioned previously. So all modern projects have to use Proto version 3. It's not default one, so we have to specify it clearly because of backward compatibility. A lot of files were created previously for using Protobuf version 2, so to avoid the breaking change, you have to specify Proto version 3. Yes, it's more modern and it's suggested syntax.
Okay, got it. Thank you. There was also mention about the versioning in general, and the question, is there any versioning in Protobuf and gRPC? Could you?
In general, you in Protobuf itself, you don't have the versioning, but it's work pretty well with unknown fields. So, for example, if you have some discrepancy between versions between servers and clients, it will not fail. So if it received some deprecated field, it will ignore it. If it's will receive unknown field, it will just ignore it. So the main part, do not mess up with indexes because it could break something. That's why it's strictly typed. So and so it have some validation. So the main idea, do not replace previous version fields, but deprecate previous ones and create a new one. So it will work pretty nice. But for gRPC, as I showed previously, you could specify some versions of it. So in general, the general approach, don't just create a new service what will work with a new version. So you could be able to distinguish between them, between versions, and keep them just in different places. So it could be almost the same, but there's some objects. So you could, it will be, in general, it will look like the same service, but it will be two different versioned services.
Okay, okay, thank you. One more question. What about security? We can add authorization header to our REST request. How can it be handled in gRPC?
So in general, you could also it's dependent on what are you using for calling gRPC. As I mentioned, it's possibly to use a plain HTTP call. So you could use, for example, some header and additional steps for checking your permissions. Beside that, I already showed. Let me find, where is it? Um, Channel builder.
So it's kind of part of the API as well.
Yeah, so you could here you could see use plain text. So it's plain text connection protocol, but for real time, for product application, you need to use another protocols. For example, use transport security. Someone was SSL. You also could override some authority, etc. So you just need to search what options, what kind of security do you need to support by your application, and just search how to use it using gRPC. Because as you could see, they have a lot of different options, methods already provided. So you could assign some additional policies. A lot of different configuration could be used for channel, for server, for everything almost. So it's already built in. So just search what you need and how to do it in gRPC. It should be pretty much simple. Yeah.
Yep, just to wrap up the topic around the functionality, I will jump through one question and we'll ask the following one. How can service-to-service circuit breaker pattern be implemented for gRPC? Are there any known tools? So is it a part of API, or are there any like external tool set, which you've mentioned, for example, like for load balancing and all that stuff, which should handle that?
Yes, as far as I remember, it should be one of the tools. I don't remember actually. If I put something here? Load balancing. I think everything should be done within this load balancing tools.
Okay, I see. So the circuit breaker is mainly like an external part of
Yes,
all of that
it
stuff.
should be a part of it, or you could search some additional tools because it's not full list of all possibilities. I just pick some of them
Yep, I
on my finger.
see that. Yep, guys in the chat also supported this answer, so posting that it's like third-party library responsibility to cover that. Okay, got it. And one more question is about the gRPC-related classes. So what are best practices in distributing the gRPC-related classes? Do you share proto files or the auto-generated code with clients?
Of course, Protobuf. Why do we need to submit, send, or something? Do something with generated class because they could be easily generated using protos, and proto syntax is much more clear than generated classes. So
Yep, and definitely it might be necessary to generate in different languages, and we should be flexible related to
yeah,
that.
so the client always could define the language they want to use using this proto. So but sending the generated files doesn't provide such flexibility.
Yep, and there is also an interesting point in the chat. There is a parity in different platforms implementations. E.g., .NET has richer libs that includes, which include, for example, load balancing. So, yep, I think that it depends from language to language, which toolset in terms of libraries is built around these proto files and like around the auto-generated code, around the server and client side like options. So, yep, it depends. And by the way, from your experience, what about Kotlin in terms of building client and server? I understand that it's quite simple, definitely quite convenient. But in terms of like additional functionality libraries, so have you, I don't know, experienced necessity in including some third-party libraries into your code?
As for me, Kotlin is perfect choice for Java projects because you could interoperate between different classes. So Java file could exist together with Kotlin and they call each other without problems on some extent, of course, because some asynchronous Kotlin coroutines require some additional steps to be used from Java. But beside that, Yeah, you could also use some additional Kotlin libraries, what quite convenient. And Kotlin provides very useful features, like, for example, extension functions, what could increase readability dramatically, because you don't need to create a nesting calls of methods, but you could create some extension function like a method, but you don't send this some data to the method, but you call this method on the class, for example, on the your object. It's much clear. Uh, in case of working with Proto and gRPC, you don't need to use these setters, builders, etc. Plus, as I mentioned, really useful in my project, especially the Kotlin features that immutability by default. So by default in Java, all lists, all collections are mutable. So to be safe in your project when you code it, you have to be secure that no one will ever modify the data somewhere in the process. So sometimes we have to use immutable libraries, for example, from Guava. Um, but for Kotlin already have everything out of the box immutable. So, and of course, null safety. It's really convenient because it's even checks all possibilities all of nulls even before you executed the code, because IntelliJ are able to show it's nullable value. I don't allow you to do it.
Yeah, that's
And
truly lifesaver sometimes.
data transformation, work with some objects, etc., is really much easier with Kotlin. For example, for Java, you need to use list, streams, find first, get, or something. In Kotlin, you have first, and it will find you first value or throw error, first or null, first or null. Single, it's expect that list contains only one value. That's all. So yeah, a lot of different features besides, yes, and of course a lot of different libraries like a Kotor. It's not always useful, for example, for mixing projects, but you could use other Kotlin powerful libraries. Yeah.
Thank you very much. I think this
And
is great inspiration for guys to study Kotlin. Yep.
yeah, and
Hopefully.
one addition, as you could see, I used the coroutine libraries mostly. In my example, you could use just synchronous uh, classes as well if you don't support asynchronous calls. But in general, working with asynchronous calls is much simpler in Kotlin, because it's more clear, easy to use, cause less frustration. So if you want to build state-of-art application, it's language to use, of course, together with gRPC and Protobuf.
Cool. By the way, guys have just posted a question. Since you've mentioned coroutines, any useful courses on them? Could you recommend something?
It's hard to say. In general, Google it.
I think the first step could be to visit our Learn platform. So
Yeah.
possibly it might share some useful insights on that, as well as LinkedIn and yep, LinkedIn
In
Learn.
general, as for me, coroutine is much simpler to understand than threads in Java or promises or RX or something. And of course, it's much easier to use. But from courses, I think nowadays you could find a lot of. You could start from the Kotlin documentation. It's pretty well made. It has some sandbox playground, so you could create and execute some code on this site, so you don't need to install anything, configure anything. So just go there, drop some code, and check it.
Thank you. And guys have also shared some links. So the first one was about the usage of metadata for custom headers in case if we need to work with authorization. And another one is that Kotlin has DSL factory methods for Protobuf. And link like to the library Kotlin generated in the Protobuf dev portal. So yes,
Nice.
thank you guys.
Yeah.
I think that we will repost all the useful links below the talk on the gRPC platform, so you will be able to reach them out later on after the session. And also, guys, while waiting for your kind of final questions, comments, or notes in any of chats you prefer, I would like to remind you that the recording of this session will be shared on the gRPC platform on the talk page. And also, in case if you like this event, please do not hesitate to use the links to rate the talk, rate the speaker, and share your special appreciation using the hero badges with the thank you button on the top page as well. So we will share the slide deck, and I think the code example.
I've already put it in the links.
Yep. Okay. Cool. So guys, you will be able to look through it later on to try it yourself and to study from practice, which is truly useful. So actually, I don't seem to see any additional questions so far. So I think we can wrap up. Thank you, guys. Thank you very much for joining us today. A special thanks for the ones who are watching us as a recording. Guys, in case if you have any questions and you haven't had a chance to post them during our session, please follow the talk page on the gRPC platform and use the comment section to post your question. We will also try to cover them. And actually, I think more or less that's all. Thank you, Sergey, one more time for the great
So
presentation.
thank you, everyone. I hope this information was useful, at least for someone.
And definitely inspiring.
Yeah, so I think it's always worth to try new technologies because you always could find something new. Do not stick with technologies you are using on your daily basis. Try something additionally, especially if it's not broke anything.
Yep, totally agree. So any study from practice will be useful for the career. So do not stop in your endeavors, and thank you very much. Have a good one. Bye.
Bye-bye.